So to start us off, the first thing we need to go through is some notations. And the notations for adding and subtracting functions, I don't know why the decision was made to do this, but this is the notation that you're going to see. The way it would be expanded is this just means we're going to take f of x and add g of x. And the other one, of course, is just the subtraction, so this one would be f of x minus g of x. So that notation is probably one of the toughest things you'll have to learn today. Let me show you how it works. Here's f of x and g of x. So if I wanted to find both the sum and the difference, oops, I guess I'll use that notation just to get you used to it. F plus g of x, that's going to be the function f of x, so 2x minus 7. And I'm going to add to it x plus 3. So the new function that I get would be 3x minus 4. So similarly, if I do it f minus g, it's going to be 2x minus 7 minus x minus 3. And you'll notice that I'm using brackets, and I do that on purpose just so that you tend to make less careless mistakes if you put them all in the bracket. Oh, have I already made it? Yeah, thank you. So things like subtractions, it's helpful just to remind yourself you're subtracting both x and 3, because sometimes people do this, right? They don't write the brackets, but now they've made a mistake because it should be subtracting 3 as well. Okay, so for this one, it would be 2x minus x is just x, and minus 10. So that would be the new function here. So I'd like you to try that on the second pair of functions right here, just to show me that you're understanding how to add and subtract and use the new notation. Okay, so I'll just try and catch up to you. You can check your work over against mine. I have been known to make the odd mistake, so you may want to double check and see if my answer makes sense. Okay, how did we do? Minus, minus. Yes, that should be a plus. Thank you. So hopefully you did better than me. Now for this next one, I just want to illustrate, there are two ways to do it when you're asked to evaluate. For example, one way that you could go on and evaluate is you could actually use the new function. So if I'm asking for f plus g of 3, I could go back up and say, oh, here is f of x plus g of x. It's already there. So that's one way we could do it. I could just say that's 3 times 3 minus 4. So 9 minus 4 is 5. It's also possible that you just go back and put them into the functions they came from. So I could also do this if I'm trying to evaluate it. That's like f at 3 plus g at 3. So the value of f at 3, that's up here. It's getting kind of cluttered, but hopefully you can follow me. That'll be 6 minus 7 is negative 1. And then here's g, so that'll be 6. And again, I still end up with 5, which you hope they're the same because we did the same thing two different ways. Okay, so you try doing f plus g of 3 on the other pair here. So you're evaluating at the number 3, not just f of x. Okay, so for the next one here, again, you can refer to the work you've already done, and you could put it in here as 2 times 3 squared plus 2 times 3.
You're using the plus one. F minus g.
Didn't I ask for f of x? F plus g. Didn't I ask for this one on the other? which is this one here. Oh, you could have done this. We're going here next. That's fine, but I thought I asked for it on the second function. Sorry if I wasn't clear. So that would be, let's see here, 18 plus 6 is 24. Or, of course, you could find the answer by just putting it into f of 3 plus g of 3. So let's see here. That'll be 9 plus 1 is 10. And 9 plus 6 is 15, minus 1 is 14. It's also 24. I'm not expecting you to do it both ways, but just since we're starting, just know there are two options for you if you're trying to do this. You can pick one you like. You may be given a question like this where you haven't been asked to first find the combination, in which case it might be easier just to do it like I have in the second example here. So it is worth knowing that there are two examples. Okay, so how many people did the subtraction one ahead of time? Okay, so we might as well just go on to that. So the subtraction here, that's like f of 1 minus g of 1. So that'll be, in the first example, this one here, that will be 2 minus 7 is negative 5, and negative 2. So I should end up with negative 3, I hope. Yep, I'm getting a couple nods. And in the second example, this one here, that would be f of 1 minus g of 1. We would have 2 minus positive 2, so I think 0. Anybody nodding? Yeah, okay. How did I get negative 3? Okay, so
X minus 10 for the first one, 1 minus 10, negative 9.
so the first one I put in, that's 2 minus 7, so that's negative 5, right?
Yeah.
Then the next one is here, x plus 3, so if I put in a 1, it's
4, and then you subtract.
4. Ah, how did I get negative 2? I must have looked at the wrong one, I guess. Yeah. So it should be minus 4. So that should be a minus 9. Somebody nodded at me on that one. Okay, anyway. So the one thing too that's different from the algebra is you're going to be expected to do this on the graphs. So I want to show you how that's possible. If you don't have equations, how could you figure out the some of these points and things? And we're actually going to have to do a little sketch as well. So for example, if I have f and g, and I guess in this one they're not labeled, but I'll have to label them for you. Let's call this one here, sure, let's call that f, and let's call that g. Maybe I'll zoom in here and hope that the resolution's a little better. Ah, that's better. I didn't think I put such a junky one in. So the first thing I want to know is what would f at 0 and g of 0 be if I added them together? So you have to go back to your graphing skills from like grade 10 probably, where you were just looking at values and graphs. That means g of 0 is here, and it has the value 3. And f of 0 is here, negative 1, 2, 3, 4, 5, 6, 7. So negative 7. So if I added those two graphs together, that's the same thing as saying negative 7 plus 3. So I'd be at negative 4. So we are going to eventually graph this. So I wanted to show you how could you get the graph of adding them together. So for now, I'm just going to put this on my graph. That if I add them together, I would be here, the purple graph, which says negative 4. Okay. See if you can do the subtraction here. What would f minus g of 1 be if you use the picture to find the values? Okay, so in this case I would have -9. So we might even have to go a step further with this. I know it's really freaking you out now, isn't it? We may have to draw the graph, and I might say graph this instead of telling me what the values are. All we're going to do is continue that process of finding out points on this graph. Okay, so let's just do the f of x plus g of x graph together, and that's the one I started in purple. Okay, so let's pick some points here. We already have 4 and -5. I add them together, and the next point that I get is at -1. Okay. How about we, let's do something really exciting. We'll go all the way out to 5. Okay. What happens if I add those two together? Yeah, so 11 is going to be right there. And I'm going to actually have to do a little bit, I'm going to have to put something in the middle there to connect the dots for me. You probably could if you had a ruler, but I'm going to do one more in the middle. So I'm going to pick right here at 3. So f of 3 is -1, and g of 3, that's 6. So if I add them together, I get 5. So it would be this spot right there. So, oops, sorry. So if I connected the dots, that's roughly what this graph would look like. And again, if you had a ruler, you might come up with a neater or straighter line than me. But we can get a picture of adding the two functions together just by plotting the points like that. Now, don't be surprised. Like, if you add two lines together, you should probably expect to get another line out of it, right? If you get like a parabola or something crazy, you want to check your work again. But for the most part, that's what, expect to get something similar like that. There shouldn't be anything too shocking that comes out of your graph for what we're going to deal with anyways. So, your turn. You want to do the minus graph or the plus graph? Why don't we do the minus graph this time, okay? Now, if you think about your algebra, when you subtract things, you can actually cancel out pieces. You may not end up with a parabola when you're done here. So anyway, see if you can come up with the graph on this one, and see if you can find those two values. Oh, sorry, I guess we should all agree. How's this? Does that work? F and G? Or did I pick the wrong ones? Which ones should we agree on? Is that okay? Yeah. Okay. Okay, so there's the first two if you just use the points on the graph to find out what adding or subtracting those functions would be. And I'm going to get rid of the red markings just so we can think about that one graph alone, the one that we're going to do for f minus g. And again, if I'm subtracting them, for example, do one of them here. This is g of 0, which was 1, and f of 0, which was -1. So if I was to subtract those two, -1 minus 1, it would be down at -2. So it's this point here. Maybe I'll do the final points in black so we can find them. And this would be 2 minus 2, which would have been at 0. I'll let you pick whatever points you want, but see if you can come up with the rest of the graph yourself and draw, connect the dots. Maybe a parabola, maybe a line, could be a constant. One other way you can do it, by the way, here's F and here's G. If I'm subtracting them, that distance there is 2. So then I know that the point here is going to be 2. Then this point is F, and I'm going to subtract G. So that's 1, 2, 3, 4, 5. So I know this one here is going to be 5 high. And we can keep going. I mean, why don't we pick one more? So this time it's the opposite direction, so you got to be careful. If I'm looking at this from here to there, that's going to be from there, subtract that one. So negative 2, take away 2 more. It'll actually go all the way down to negative 4. So even though this is a distance of 4, it's negative because F's on the bottom. But hopefully you can see now that this is what the graph would end up being if we were to connect the dots. Any questions? Can I see how many people were able to come up with a line like this? Okay. Okay. So let's just try doing the sketch, the graph. If these were the two, we'll start on the left side. You want to do the plus or the minus for the left one? We'll do the other one for the other graph. So which one do you want to do here? Oh, are they both there? Sorry, they are both there. So we'll do the positive here. Do this, oops, sticking there, f plus g of x. And if you've got your notes printed, do f minus g of x on this one. So I'm going to do my final one in purple. So let's see here. So we're adding this one. And if you're not sure what the graph's doing, then just try getting some extra points to help make that decision with you. And 2, so that'll be 8. Okay, so maybe I'll try just a couple more points. I think I'm getting the picture here. So 3 and 15 is going to go up to 18 this time. So that'll be there. And I'll do one more. This is 4 and 18, so that'll be 22. Now, it's not exactly a line that you're getting out of this. one thing that you can probably reason with if you're trying to figure out, well, Mr. Joyce, when am I supposed to pick more points or less points? Well, the graphs are the same until here. This is where they change shape. So right there, you see if you look on the left side of that graph, the lines are the same. If you look on the right side, the lines stay the same. That's where they change. So you should expect to have two different pictures then, right? One for the left, one for the right. So that's why I get one graph like this on this side that all of a sudden gets steeper and goes this way on the other side. Okay, so that would be f plus g.
So we have to get every point?
You don't have to do it enough till you're confident you know the shape. And again, the reason here you know that you have to do both sides is that's where the graph changes, you know, the two make different pieces on the left and right side of that. Okay, so try the subtraction problem. Let's make this one here f and this one here g. Okay, so I'll try to catch up to you here. Again, I'll do my final graph in purple. And as I mentioned, one other way you can look at the subtraction problem is you can think about how far apart they are. That's the distance between the two functions. So in this case, it would be 4, which means I'd put my point here at 4. So maybe I'll just do one more, and then I think I have the shape enough that I can do it. So this is 16, 17, 18, and 3 high, so 15. Oops, did I get that one? 16, 17, 18, and that one is 3. Oh, that's why. 4 high. So it should be 14. So 14's there. Okay, so I have the first line I have is about like this, and then it changes on that side. So that purple graph is the one which represents their subtraction. Bored yet?
Yep.
Okay, let's move on. Guess that's not really a fair question. I can probably ask you that at just about any time, huh? Okay. So students at the school decide they're going to sell t-shirts for a fundraising activity if their costs are $250 and per shirt is $4. So maybe like the $250 is like to rent a booth and pay for, you know, some fixed items that they need to do. It says if they can sell the shirts for $10, we're going to sort of model this one through using those adding and subtracting. It's a kind of a lame application, but we'll show you how this works. So if we want an equation for cost, you give me X shirts, it costs 4 times the number of shirts. Revenue, if you sell X number of shirts, you're going to make $10 per shirt. And the profit you're going to make, well, what do you think? Good, yeah. So profit, we can represent it a couple ways, right? That's the revenue that your business makes minus your costs. So that's 10x minus 4x. $6 a shirt, which is kind of what you would expect, right? If they cost 10 and you sell for 4, it's $6. Okay. Now, the only thing we don't have in here is my cost is actually going to be the fixed cost that needs to be included in here, right? So I actually need to put the plus 250 in, or I don't have this problem worked out. Which means here, the profit is going to be 6x minus 250. because that's our fixed cost at the beginning. And I think at this point we'll turn to a graphing calculator to give us some help. Okay, and I will look at that profit function. So let's go to 6x minus 250. So this is going to show us a picture of our profits. A good window, you don't need to see negative t-shirts. And if you think about, if we sell 100 t-shirts, we're definitely into profit. In fact, if we sell 50 t-shirts, we're into profit. So that'll be enough to kind of give us an idea for this question anyways. And I know that at 0 t-shirts, I'm going to start at 250. And, you know, you can make a guess. If you make an educated guess, you're going to find $300 is, you know, well, 300 minus the, so it'll be $50. We don't need quite that much. Again, if you don't get the right window, then just make a new window on your computer. You don't have to be so precise about it. There it is, and this is the one I'm looking for here, which is how many t-shirts to make a profit. So let's go calculate the 0. So on the left side, somewhere about there is good. And then on the right side, and a 0. Of course, you could just solve it by hand, but this is 42 shirts. So the other reason that I wanted you to think about the picture is, what's the domain and range of this? Why don't we talk about domain? Yeah. And what about the range? Yeah. So one thing that's going to help you out when you start thinking about domain and range is usually the first time you're taught this, I mean, this has probably happened to you, your teacher said, well, domain is all the x values in the picture and range is all the y values in the picture. Now that's not very helpful to us if you don't have a picture. The better way to think about it is the domain is all the values you're allowed to use. Okay? So anything permissible in this situation, everything bigger than or equal to 0 is allowed. The range is the set of values that come out of the domain. So if you use these values, this is what comes out of the function. So that's the better way to think about this when we go forward, in case that was your grade 11 teacher. So we have one last thing to do, and that's multiply and divide. Yay. So why don't you just, this is the notation. We'll see if you can do it without my help. This notation means f of x times g of x. And this notation here means f of x divided by g of x. Okay, let's see if you can be experts at it. See if you can come up with the new function. We'll talk about domain and range together in a second. In this case, you can't move x to the outside. You mean this x squared? Yeah, you can't do it by subtraction. You can only do it through multiplication. So it would have to be x squared times the whole thing in order to get outside the square root. And let's see here. We have x plus 2 over x squared plus 9x plus 14. All right. So for this first one, let's think about, how would we state the domain? What do you think has to happen when we put these two together? It has to be positive. It has to be positive for both, right? So when we combine these two domains, the only way it works in the new function is if it still works for both. So here, what we're looking at when we put them together is x squared minus 9 would have to be greater than 0. And so one way we can come up with this is with those lovely little number lines that we started. And the pieces again are x minus 3, x plus 3. And their product is x squared minus 9. So let's take a look at what happens in those factors. Here's negative 3. Here's positive 3. So in this x minus 3 piece, it's going to be negative anywhere over here, but positive over there. And this one will be negative, positive. So if I put the products together, it's positive there, and positive there. So I can see then from the new result here that x has to be less than negative 3. Or x has to be greater than 3. Now, if I was to put those in, does anybody see any problems there?
Less than 0?
Yeah, so we talked about this in logs, and this is still the same thing. Whenever you're not sure and you're trying to wonder, where do I find the new domain, or where do I check the restrictions, it's always at the very beginning, the first thing you did. It's always right back here, because after this, you did some algebra and you made changes. Once you make changes, that's when it gets harder to track where it's going. So this is where we need to look back on. It's not going to work if we were to use that for the domain, because we did a bunch of changes. So the good news for you is it's a lot simpler than you think. You don't have to go through all that algebra and hunting for new solutions. You just go to the first step. Here, x has to be greater than negative 3 to work, and here, x has to be greater than 3. So really, in order to make sure this works, I have to make sure both of these are true at the same time. How do you do it? Just pick the biggest one. Now they're both greater than 0, as long as x is greater than 3. So that's the only one we want to keep for the new domain. And how do you know if it's correct? Because when you double check the very first step, it works for both functions. If it doesn't work for both, it's not going to be the correct domain, and it's always the first step because you make changes after that. So I would answer like this in my question. I would say f times g is x squared minus 9, and I would say that x has to be greater than 3. Yes?
Can it be equal?
Yeah, it can be equal. Thank you. Nothing wrong with a 0 there. All right. And now what about the range? What kind of numbers come out of square roots? They have to be positive, right? They can be 0 and higher. They can't be anything other than 0 and bigger. So this one, the y values have to be greater than or equal to 0 as well. So remember, if you think of domain as what am I allowed to put into this function, and range is what comes out. What comes out of square roots are positives. So the rules with quotients are just about the same. The only difference now is that, here's the thing, new domain works for f and g. And what do you think the and is now that I've made a fraction?
X plus 7 cannot be equal to 0.
You're on the right track. And in more general terms, I would say g cannot be equal to 0. So basically my problems are, they have to work for both functions, and because I'm dividing them now, I also have to make sure I'm not dividing by 0. So let's take a look. This is all real numbers. Okay. This is all real numbers. But I'd be dividing by 0 when x is negative 2 or negative 7. So the domain of this new function is x can't equal negative 2 or negative 7 because it works for all other numbers except for where I divide by 0. Now this one's a little trickier. It's a fraction, so you have to be a bit more strategic. What do you think? What's the biggest number you can get out of that fraction? You can never. Okay. How did you do that? You got 1? Negative 6? Well, right now you're probably just thinking through integers in your head right now. And that works, but remember you can be more creative than integers. Like if I wanted to be, say for example, 1 over, I'm going to make this negative 6.9999999. Maybe I'll do this about 100 more times. And then add 7 to it. What's going to happen to that? On the bottom of the fraction, it's 0.000. So what's going to happen when I do the whole thing, though? Well, it's going to be a very, very big number when I do this, right? So huge numbers possible. Okay, what about when I go the other way and I try to strategize, like what about negative 7.000000000 la 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 1? Now what happens? What do you think? Well, it's a huge negative because I'm dividing by a negative. It's exactly the same as the first one, but it's negative. So I've got huge negatives, huge positives. There's actually only one number I'm not going to get. Can anybody figure? Yeah, 0 is the only number I can't pull out of this thing. So the range is y greater than 0 and y less than 0, or you could simply just put y is not equal to 0 for the range. Okay. When we do calculus, we'll spend time on. You'll be pros at this. This will be kids stuff once you learn some better techniques for it. I don't know if that makes you feel any better, but kind of wondering, what's he going to be teaching us? So the last thing we'll do here then is a pendulum loses 3% of its amplitude due to friction. If the amplitude is modeled by 15 cos t without friction, create a model for the actual amplitude. Now, because I'm a geek and I thought this was kind of a neat way to blend your last couple of chapters together, every time it swings, it loses 3%. Can you think of a function that you could write for that?
0.97.
Yeah, 0.97x. That's how much percent you've lost after each swing of the pendulum, right? And then the other function you have is the amplitude. Well, I'll use x here even though we weren't, right? So you've got the amplitude going up and down, but now friction comes in. So how do they affect each other? Well, this is what percentage you're allowed to keep. So it's going to be 0.97. That's the percentage of the amplitude that I started with. So their product makes the actual, and this is more so the way it works in real life, right? Is things, they don't bounce forever. They sort of, friction or gravity takes over. But this would be what the actual amplitude would look like. And of course, we can answer that question about when will the amplitude be less than 12 feet by looking for where that happens on the graph. So 0.97 to the x times 15 times cosine of x. Make sure you're in radian mode. And I'm going to have to adjust my window from the last problem. Sure, let's try 50 seconds and see what it looks like. That's going to be a lot, though. Let's try 20. We can always zoom out if we need to. I know the amplitude is, so it's going to be negative 15 to 15 is going to give me that whole picture. And let's have a look and see what we get from the picture. So it's just like the cosine graph that you already know, but look at that. Now it's it's getting shorter on each bounce, right? That's the friction coming in. So let's just see if that's enough then to find the number 12. Yeah, so now we can see when it's not going to be 12 anymore, right? So what I want to do is find, that's the time right there I'm looking for, because here it does get to 12 feet because it goes past 12 feet and then down, right? It will never get up to 12 again because that friction, if you're where the mouse is now, that's what I'm going to try to find. So I'm going to go, I should probably zoom in on that just to make sure that I get the right point. So let's see, 1, 2 tick marks was enough, and my window goes up by 5. So we could stop at 10 here. The answer is somewhere between 0 and 10. And I'll use a scale of 1 just to make it easier to see. So okay, so now I'll find the intersection. And you're going to have to be pretty accurate here so that the calculator doesn't find the wrong intersection. So I'll put them fairly close to what I think is the answer. And I'll guess about there. Now, did it find the right one? Yes, okay, so it found the right one over here. So the last time it happens is at time equal to 6.5 seconds. So like if this is like Indiana Jones, you know, and there's that like sawing, swinging, you know, it's like in you're 12 feet tall, then you know after 6.5 seconds you got it. Anyway, I can't think of a real practical reason other than that, you know, it brings the last couple units we did together on trig and exponents. So in terms of your homework to practice those, that's where they come from in the 2 sections. If you're asked to do any graphing in this section here on products and divisions, then just use your graphing calculator, please. It's not a skill that you're going to need to know well enough to do by hand. So use your graphing calculator on those.